Now, as I said, we're going to streamline this and mainly focus on the organic molecules. And we're going to move away from the traditional method, although it's very important. You have to remember from the traditional method is that you have to have a single covalent bond, a double, a triple. Remember the octet rule. All of that is key. The octet rule is always important. But when we get to organic molecules and written in this formula, it's going to become like second nature. You will quickly understand what to do in this case. So here's a molecule that I'm asking you to draw. So here it says generally you place atoms in the order they are written in the formula, and carbon would be the central atom. Single bonds are used to give the atoms the octet, or 2 electron for hydrogen. So when you look at this formula, what you should be doing is start writing this and attach again those atoms. So if you see here, this C attached to the 3 H's, via single bonds. And of course, since we are done with the H's and there's now a bond between this C, the first C, and the second C, and then as we use these 2 H's, we have an O, and of course the H is attached to that O. Now, almost done. Why? This carbon has 8 valence electrons, or 4 bonds. Remember the H, the honk, 1, 2, 3, 4. So the H has 1. H has 1. The C has 4. You can see the 4. And on that one. But we have one more now. We don't have a nitrogen in there. We have an O. So what do we do? Well, for O, it says you need to have 2 bonds. And we do have 2 bonds. Here's a bond. Okay. And then let me erase that one so you can see it. Okay, only if I can. Okay, so we're just gonna circle over it here. It's okay. Now, what do we have to do in order to give oxygen the octet? So far, it has 4. So if you can't accomplish that by bonds, then you put the lone pairs. This is similar to water. If you look at water, water is a molecule in which oxygen has 2 bonds and 2 lone pairs for the octet. So again, remember this method and it's going to help you. Now, in terms of double bonds, we're going to see that. So like in the next one here, we have a C with 2 H's. And another C with 2 H's. Okay, now again, the H has 1, so it's happy, but C needs to have 4 bonds. And this is a neutral molecule. It has no negative charge or positive. But if you look at each carbon, it only has 3 bonds. 1, 2, 3. Of course, for this one, 1, 2, 3. So what do you have to do? So if you put a lone pair, that's not going to work because it's going to give the octet to one carbon and not the other. So in this case, you put a double bond. And that would take care of the bonding. So now each carbon has a four covalent bonds.